I'm Glory Pan. Today I'm going to fry an egg and explain the science behind it. The purpose of this experiment is to observe the transformation of protein when heated. The ingredients are very simple and tools include a fresh egg, a frying pan, a stove, and oil. The purpose of the oil is to prevent the egg from sticking to the pan. Have you noticed when cooking egg or fish they tend to stick to the pan? That's because chemical bonds are actually forming between the food and the metal surface during cooking. However, when oil is added, the oil acts like a barrier and separates the egg from the pan to prevent sticking. Before we start the cooking process, let us take a close look of the structure of the egg. So I'm going to take the egg, bring it over here. Before we start the cooking process, let us take a close look of the structure of the egg. We can see there are two distinct structures of the egg. The clear part is the egg white and the orange center part is the egg yolk. The egg white contains mostly water and some protein like ovalbumins and globulins. On the other hand, the egg yolk contains protein, lipids, and minerals. That's why people who are on diets prefer eating eggs without the egg yolk to reduce the consumption of lipids. From a molecular level, the proteins are composed of thousands of amino acids bound together into long chains that are folded into compact balls held together by weak chemical bonds. The negative charge of the protein repels each other and keeps the egg white watery and loose. The egg yolk, on the other hand, contains mostly lipids, which are nonpolar and don't have any charge. So in egg yolk, the protein's negative charge are neutralized by the uncharged lipid, which makes the egg yolk protein less repulsive to one another. That's why the egg yolk seems less watery compared to the egg white. Okay, let's get started with the lab. First, we need to turn on the heat. Okay, turn on the heat and then add 1 tablespoon of olive oil. So now we are going to pour the egg in and wait a few minutes for the egg to absorb the heat. The heat causes the bond to break apart. Protein uncurl and form new bonds with one another. As the heat increases, the protein chain will tangle into a web structure, and the water is dispersed in the protein web and no longer able to move around freely. And that's exactly what we observe. The egg is starting to solidify. Then, as we cook it for longer, the egg starts to shrink a little, because the protein web is becoming tighter and water is evaporated by heat. When the egg is fully cooked, the structure is held together by disulfide bridges, cross links, hydrogen bonding. Another popular method of cooking an egg is boiling it. Sometimes when we boil the egg for a long period of time, we will notice the egg yolk turning green and smell like sulfur. It is because the iron in the egg yolk will react with the sulfur in the egg white to form green ferrous sulfide and hydrogen sulfide gas. To avoid this, we can simply boil the egg for less time and put the egg into cold water to stop the cooking process. One interesting fact about egg yolk is that it is a great emulsifier. We can use it to mix materials that normally don't mix well, like oil and water. Egg yolk has this unique ability because it contains phospholipids that contains a hydrophilic water-loving head and a hydrophobic water-hating tails. One part of protein will stick to the water and the other part stick to the nonpolar oil part.